Good morning, Funk University. This is Professor Frank, the coolest motherfucking teacher on YouTube. What up, gangsters? Today we are going to be speaking about math, in particular probability. Let's get into it. Before you endeavor on any type of probability question, you need to make a decision. Is this going to be an independent or a dependent probability question? Well, what does that mean? When you flip a coin one time, there is a 50% chance you get heads and 50% you get tails. If you flip a fair coin a second time, it's the same probability. What happened in the past has nothing to do with what will happen in the future. Therefore, simply flipping a coin is an independent probability event. Whatever happened in the past has no bearing on what's going to happen in the future. If you flip a coin 100 times and you get heads 100 times, when you flip that coin for the 101st time, the probability of getting heads is still 50, as long as it's a fair coin. No matter what happened in the past, each time you flip the coin, it's an independent action. A dependent probability question will have some form of action that relies upon what happened previously. Let's explain. Let's look at this bin of video games. There's 6 video games that we can choose from. Now let's say we blindly stick our hand in the bin and select a video game. The probability of selecting Red Dead Redemption on the first try is 50%, or 3 out of 6. Remember, in probability, the equation we want to find needs to account for the total. So we count up the total, there's 6. And the number we want to get, which is the probability of grabbing a Red Dead Redemption, the number we want to get is 3. Therefore, probability equals 3/6 or 50%. So let's assume we Red Dead Redemption 2 on our first grab and we keep it to the side. Now, the second grab in only has 5 games to choose from. Therefore, this action, removing something from the bin or a jar or anything and not putting it back, makes this type of equation a dependent probability equation, because now the probability of the second grab is dependent on what happened in the first. So here, if we want to determine the probability of grabbing a Red Dead Redemption on the second try, we need to understand that it is a dependent question because the probability changes. Now the total is 5. And if we want to grab Red Dead Redemption, we only got 2 tries. So the probability of getting Red Dead Redemption on the second grab, if we don't put it back, is 2/5. No longer is it 3/5 because we removed it. So if the question informs you that when you grab something out of a bin, you will not put it back, you have a dependent type question. And you just got to be aware of the difference between the 2 types of probabilities. One that's independent and another is dependent. We can easily make this question an independent question by saying that after the first grab, no matter what we get, we're going to put it back in and then grab another time. If we replace the item that we grab, then it would be an independent question. Each time we make a selection, there will be the same amount of probability, and nothing we did in the past will affect the current chance of grabbing Red Dead Redemption in this example. So just to be clear, understand that there are a difference between independent and dependent. The real problems relating to probability will need to use this formula. And it basically says that the probability of anything is calculated by dividing the total number by the number of what you want. So what does that mean? Well, this formula is very important. You need to memorize it. So the probability of anything is equal to the number of what you want, and I'll explain that, over the total number. Total number is easy, but sometimes you need to do calculations to get it. Here in this example, the total number is 6. You simply count the number of items. So the total number would be 6. If we want to count the probability of selecting Red Dead Redemption 2, that is the number of what you want. So we want that number, 1, 2, 3, and that would be 3 over 6. So this formula is important because there are situations where they will not provide you with either the probability or one of these variables, and you will need to do some calculations. Let's look at a typical problem for where you're going to need to use this formula. Again, probability equals the number of what you want over the total number. A lot of problems will give you some missing information, and they're going to ask you to solve for something in particular. For example, a common problem will set forth that there are 3 types of items, in this particular question, games, in a bin. There are 4 Red Dead Redemption 2 games. The probability of selecting Red Dead Redemption 2 is 1/3. What is total number of games in bin? Okay, so this is a standard question. The only information we're getting is that there's 3 types of games in this bin. They tell us that there's 4 Red Dead Redemptions, and the probability of selecting the Red Dead Redemption is 1/3. First, we ask ourselves, is this a dependent or independent question? And the answer is it's a independent question. There's no indication that we're going to be moving out any items. In fact, we're just trying to get the total. So when you get a probability question, a lot of times you need to just figure out what the total is, even though you're not given all the information. So go back to your formula. The probability of any event, in this case, we are doing the Red Dead Redemption, so I'm just going to put an R there, is going to be equal to the number of items that we want over the total. So the number of items, they told us that there are 4. So we have this. And the probability is given to us. It's 1/3. So we break that formula down. And so 1/3 equals 4 over the total, which we don't know. So we're just going to use it as T. Keep it as T. Now, you got to be able to use algebra to solve for the total. So in order to get the T by itself, we're going to multiply each side by T, and that will cancel this out. And 1/3 times T is 1/3 T equals 4. Now, to solve for T, we need to divide each side by 1/3. So we divide by 1/3 here, and that cancels out. Now 4 divided by 1/3 is equal to what? Do you remember your fractions? When we divide fractions, we flip the right, we don't ask why, and then multiply. So it'll be 4 times 3 over 1, which is equal to 12 over 1. So the total is equal to 12. Did you see how we got that? So again, with our formula, probability of the event of selecting Red Dead Redemption is equal to the number of items we want. And when they say the number of items you want, it's the number of items that you're looking for the probability. In this case, it's selecting Red Dead Redemption over the total. Here, we didn't have the total, so we needed that formula, and we needed to know how to use math to figure out how to get the total number as 12. Let's say the question asks for something different. it informs us there's 3 types of games: Red Dead Redemption, GTA 5, and Leisure Suit Larry. Again, they inform us that there are 4 Red Dead Redemptions, and the probability of selecting a Red Dead Redemption is 1/3. So we know the probability is equal to the number we want over the total. We don't know the total. We know that we're missing the 2 types of games, and we know that the number we want, as they inform us, is that there's 12. We just went through this. The number we want, as we were informed, was 4, and we calculated the total to be 12. And the probability of selecting the Red Dead, as they gave to us, is 1/3. When you break this down, it equals to 1/3. So we know that there's 8 other games because we know the total is 12, but we don't know how many of each there are. The question then informs us that there are 1/4, and then informs us there's a 1/4 probability of selecting GTA. So what do we do with that information? Well, we know the probability is equal to the number we want over the total. We know the total is equal to 12. And if we know that the probability is 1/4 to select something, and you know the total, then you can just simply multiply 1/4 times 12, and that will give you 12 over 4, which will give you 3. So if you are informed that the probability of selecting a game is 1/4 and you know the total, you simply need to just multiply the probability by the total, and you will get that answer. And since we know that there is the one last type of game, Leisure Suit Larry, we can simply say we know the total is 12, and we have 1, 2, 3, 4, 5, 6, 7. So 12 minus 7 is going to equal 5. So all in all, we were told there's 3 types of games, and we're only given the probability of selecting Red Dead Redemption, and we're also given the number that was in there. And with that, we're able to calculate the total and then move from there. So the key to these problems is getting the formula down. Probability equals the number you want over the total. And once you get that total, if you have the probability, you can always multiply probability by total to get the number that's in there. This is Professor Frank, the coolest motherfunkin' math, English, and general studies teacher on YouTube. Have a good day. I'm funkin' out.